Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ikram Zainuddin as the first presenter for our group, which is group 3. So by referring the instruction given for the group 3, there are two sources, which is 240 and 30 with degree of 15. The capacitor impedance is 45 farad. Inductive impedance, resistor 20 ohm, the inductor is 40 Henry, and the industrial load is 6 plus J12 ohm. So let's construct the circuit. So first, there are two AC source. Where the V1 is 50 frequency. With 50 frequency, the voltage is 240 volt. Source 2 is 30 volt with the same frequency, which is 50 Hz, and the degree angle is 15. Okay, so for the first load is the capacitor. For the inductive is resistor and the inductor. For industrial load, our industrial load is positive, which means we need to using the inductive or lagging. So there are resistor and there are inductor. For the capacitor, the value for the capacitor by using the initial value from the instruction is 45. So we convert it to get 70.74 in farad. For the inductive, there is 0.1273 Henry. For the resistor is 20 ohm. Okay, let's convert for the Z load, which is below calculation. It's 0.03820 Henry. For inductive and industrial load is 0.03820 Henry. For the resistor is 6 ohm. So we tapping or we connect each component with the wire. And not forget for the grounding, it is most important, but it is the mostly careless. So our circuit is done. So I will pass another presenter to conduct the value of each component, which is the voltage and the current. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul Haris. My number is DE200057, and I will present the voltage and current for the capacitor. So, we firstly we do a voltage first. So, we apply the voltmeter at the capacitor by using technique by do a parallel. We adjust the value first. So we pick the value at the max of the waveform. So we can see we get the value is two 291.51 volt, and the time delay is 965.51 milliseconds. So that is for the voltage side. So we we do the current. So the current we just put it here because the current going through the capacitor is at the line 1. So this is enough to put it here. So let's run the simulation first. So we adjust for the value. So at the top of the waveform, we can get the value of the current, which is 6.4994 ampere, and the time delay second is 1.0205 seconds. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Muhammad Shafiq bin Nasri. Now I want to present about the inductor to find the voltage and current at inductor. Okay, first we need to put the voltage reference. Okay, now I run the simulation. Okay, for the graph, I get the for the V voltage peak is around 75.26 voltage, and the time delay is around 2.01 second. 2.01 millisecond. Okay. Next is for the current. I want to find the current. Okay. Current is at this point. Okay. I run the simulation. Okay. For the graph, we can see. Oh, okay. You can see the current that I get is around 1.88 millisecond, 1.88 ampere, and the time delay is around 1.44 millisecond. Okay. Thank you.
Hi, my name is Kirian Ray, and my matric number is CE220029. And I am here. I would like to explain about how to calculate the voltage and the current for the Z load. Okay, first of all, we take the voltage node and we click the voltage negative node button and we place it over the circuit. Okay, and we must remember that always voltmeter should be connected parallelly, and after we run circuit and we could see the graph. Hold on. Okay, and in order to view the graph in order to have a better view on the graph, I am going to adjust the voltage to we're going to put it at negative 200 volt for the minimum value and 200 volt for the maximum value. And now we could see the graph clearly, and we could see that the voltage peak to peak is 62.838 volt. And next, for the current, we remove the voltage probes and we go to the same button and click current. In order to find the current for the Z load, we place the ammeter node there, and then we run the graph. In order to view the graph better, so I'm changing the value of minimum maximum, which is negative 5 and 5 ampere. And now we could view the graph clearly, and we could see the current peak to peak is 4.6725 ampere. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazrin Biamaso. My numeric is CE220010. In this video, I will discuss with you about how to get the Zmax current and Zmax voltage. So to get the Zmax current, we need to put the current is over here, then run the simulation. Then need to pause. So the value of Zmax current is actually 4.6388 ampere. To see the graph, we need to click the graph section over here. And need to be small. To get the in the graph, the value is 4.6388 ampere. Okay, then we need to find the Zmax voltage. First, we need to stop the simulation first. Then change the current with the voltage, and then put it at here. Then run back the simulation and pause it to see the value. The value that which we got is for 41.529 volt. Then we click the graph section to see the graph. The value that we got is 62.838. That's all. Thank you.